ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
Measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times length plus 2 times width.
Good afternoon! Welcome to another exciting, awesome season of the Tele Award-winning Math Homework Hotline. Count on us! We're back! Woo! And we are so glad that you have joined us today. So, let's get started. My name is Coach Sun, and I'm here with my awesome, amazing partner, Coach Davis! Coach is back. And we are so glad that you are here, and we are even more excited because we actually already have callers, which is so fabulous. But we do want to let you know that we are here for your math homework questions, something you've been wondering about in math. That is what we are here for today. So we would love for you to give us a call. The number here at Count on Us is 301-772-0080. And just for calling, your name is going to go into this awesome treasure chest.
Because we treasure all of our callers.
We do treasure you all. Absolutely. So we're going to, at the end of the show, pull a name, so make sure to stay tuned. We also have some challenges, which Coach Davis will talk about in a moment. And if you do rise to the challenge and get that correct, your name goes in the treasure chest twice. And I do believe we actually have some special prizes for the first 5 schools that are calling this. Different schools that are calling our new season here at Count on Us. So we look forward to sending those prizes to those schools. So without further ado.
If this is your first time tuning in, we'd like to welcome all of our new callers, our first time fans. And we also have some students that we're sure have listened and watched through the years. So our frequent fans, we welcome you back as well. Now, Coach Sun mentioned some challenges. I just want to draw your attention to those.
That sounds great.
This is called Challenge 24.
Love
and
it.
the reason that it's called Challenge 24 is because you are challenged to get a total of 24. You are going to use each of the numbers that are on the wheel, each number only as many times as you see it on the wheel. You may add, subtract, multiply, or divide, or any combination of those 4 operations so that you get a total of 24. So if you'll take a few moments to jot these down, we've identified them by alphabet. This is card A, and this is a 6. And if it was filled in, it would be a 9, and we don't have one filled in. So this is 6, 2, 7, and 1. Use each number as many times as it appears on the card. Card B
is 2, 5, 6, 8. As Coach Davis mentioned, go ahead and write these down, not only so you can solve them as we're working through the show, but also it's just fun stuff to do with your friends and your family. So write them down, solve them.
And card C, 2, 8, 7, 2.
And card D, 3, 2, 5, and 3. So since you see 3 2 times, you would need to use it twice.
Yes, and so again, the challenge is to come up with a total of 24. Adding, subtracting, multiplying, or dividing. And you may watch us here. And if you happen not to have Comcast or Verizon, you can actually tune your television into you can actually tune in on the World Wide Web at your Prince George's County homepage and click on the Students link and look for homework help.
Now, we would like to get started because we do already have the phone lines lit up, which is so awesome!
Yes.
We are going to ask if you are holding to continue to hold, and we will make sure to help everyone in the order that they called, and we will get to you, so stay tuned. Let's get it started! Woo! Okay.
All right, here we go. Is that Angie? Angie, are you there? Hello?
Is Angie our first caller of the season on Count on Us?
Yes.
Yay, Angie!
All right. Angie, are you calling from Beltsville?
Yeah.
Okay, and would you like to give us the name of your teacher?
Miss Hart.
Miss Hart. And what grade are you, Angie?
6.
Sixth grade. Well, welcome. And we're going to ask all of our callers, when you call in, if you will turn the volume on your television set or whatever it is you're tuning in all the way down and just listen to us on the phone if you're calling on a phone. That way we won't have the background noise, the delayed response that we can hear in the back.
Okay.
Okay?
Okay.
Now, Angie, are you working with decimals as mixed numbers or mixed numbers as decimals?
Yeah.
Okay. Well, Coach and I will do our best to assist you. So if you will explain very clearly and carefully what the problem is, we'll write it down and assist you. So you're working as a decimal to a mixed number?
What was that?
What is the problem that you would like assistance with today?
0.282.
0.282.
Any chance you could read that to us as a decimal with the place values in there?
282,000.
Okay. So the best way to think about reading a decimal, if I just happen to see the number 282, whatever name I would use, I would call it by, that's the same name that I would use, and I would just identify the place value of my last digit, my digit furthest to the right of the decimal.
Okay.
Okay. So how would I say 282?
The thousands?
This final 2 is in the, well, let's take a look. Let's just go with the blue right now. How would I say this particular number?
Thousands.
I think you're thinking of this place value, correct?
So this final 2 is in the thousands place. You are correct.
With the decimal there, it's in the thousands place, yeah.
Okay, this is the thousands. So we would say 282, and then give it a last name, thousands, to let us know it's a decimal. Okay, and that's going to help us out a lot when we're trying to write it as a fraction.
Was there another part to the problem? I kind of interrupted you there to have you read it. Was there anything else?
No, that's fine. That's all.
Okay.
Thank you.
Okay, sure.
Okay, so you would simply like to write this decimal, 282, as a fraction or a mixed number. Is that correct?
Yeah.
Okay. All right, well, we'll try our best to help you with that. So the number is 282, and you said the last name would be thousands. So 1,000 is written as a 1 with how many zeros?
3.
3 zeros. So this is thousands. And I simply put 282 as my numerator. And so now we have this decimal written as a fraction. Now the only other thing we might want to do is simplify. Okay, are you required to simplify?
Yeah.
Okay, so do you know how to simplify?
A little bit.
A little bit. Sometimes that's tricky. The best thing to help with simplifying is thinking of common factors. So thinking about the numbers that we can multiply to get 282 and also 1,000. Now, one thing that you can think about is your divisibility rules. Since I see the last digit is a 2 and a 0, I automatically know it's divisible by 2. So I'm thinking, I know that 2, if I divide both the numerator and denominator by 2, I haven't changed the value of the fraction itself, but I am simply using smaller numbers to represent it. Does that make sense?
Yeah.
Okay, so let's divide. I know that 2 divides into 1,500 times, and 2 divides into 200 100 times. 2 divides into 80 40 times, and 2 divides into 2 1 time. So now I have as a simplified fraction 141 500ths. Now notice that if I look, I don't have an even number as my final digit. If I add 1 plus 4, that's 5, plus 1 is 6, so I know that this is divisible by 3. 5 plus 0 plus 0 is 5. That's not divisible by 3. So we've actually simplified this decimal into a fraction in simplified form.
Excellent. And I know you did mention mixed numbers. And remember, a mixed number has what in front of the fraction?
A whole number.
Right, exactly. So that would happen if you had a decimal right here that you were changing to a mixed number. We would need to have a number in the ones, tens, or any of those place values to the left of the decimal point. So that means that would convert to a mixed number if you had a whole number. Since all you had was decimals that were less than 1, then that's why it became just a fraction instead of a mixed number. Does that make sense?
Yeah.
Okay.
So the whole
Excellent.
number would be 0 because the whole number in front of the
Right.
decimal there is 0. So the mixed number is simply the fraction.
Okay.
All right.
All right, Angie, we loved having you call. You were the first caller of this new season, so we really appreciate it. We actually have at least 4 other callers, so we're going to ask if you would like to do the challenge, if you could call us back in the second half of the show, okay?
Okay.
Okay, but your name is already in the treasure chest. Yay, you are first caller of the season. Thank you so much, Angie. Have a great afternoon, okay?
All right.
Okay,
And we're
thank you.
all ready for, is this Keon?
Good afternoon. We're saying your name right, Keon?
Yeah.
Welcome to
Welcome,
Count on
Keon.
Us. How are you today?
Good.
Excellent. We are so glad you called. What school are you calling from, Keon?
I'm calling from Allenwood Elementary.
Allenwood! All right, so Allenwood is our second school. Remember, we're having a competition
Uh-huh.
for the first 5 schools.
5 different schools.
So that is awesome. We are so glad that you called. So how can we help you today, Keon?
What grade? Can I interrupt?
Yes, thank you.
What grade are you, Keon?
I'm in 6th.
5th grade. Okay.
6th or 5th?
Now,
What grade are you?
huh?
What grade again, please?
I can't hear you.
What grade are you? Tell me one more time.
6.
6th grade. That's our
Okay.
second 6th grade caller. How
I
exciting.
love it.
Okay, so what can we help you with today on Count on Us, Keon?
In our class, we're working on multiplying and dividing fractions.
Okay.
Excellent. Okay, so is there a specific problem that you would like help with?
Yes.
Okay.
It's a word problem. It says Bill wants to run a total of 4,000 meters in 5 days.
Okay. Can you start just the beginning part? I heard the second, but not the beginning. Can you start that one more time?
Bill wants to run a total of 4,000 meters in 5 days.
Okay, 4,000 meters in 5 days. Okay, got it. What's the next part?
The table shows how far he runs each day for 4 days. Each lap is 400 meters.
Okay. All right, so is there a table to go with it?
Yes.
Okay, what does the table look like?
Oh my! It's like it is. It's like that, and then split not in half, but like a quarter. No, long way.
Let's do how many rows and how many columns. Remember, rows go across, they're horizontal. So how many rows are there in your table?
It's 5 columns.
Okay,
5.
5 columns. So columns go
down.
up and down, and rows go sideways.
Straight.
Okay. So 5.
Column straight, like the way she's doing already.
Okay. All right, and then how many rows? How many times do we go across?
You go across 4, like that, and then you go down. You go across 3 times.
3 times. Okay. All right, how does that look?
Actually, it doesn't look exactly like that, but it has this on it. It has Monday, Tuesday, Wednesday, and Thursday.
Okay. All right, so we've got Monday, Tuesday, Wednesday, Thursday.
Yeah.
Okay.
I was trying to figure out what is Friday.
Okay. Okay. And then and then we have, each lap is 400 meters.
Yes, that is 1 1/4.
Okay.
And then Tuesday is 1 1/3. And 3/4.
Okay.
Wednesday is 1 5/8.
Okay.
And Thursday is 2 1/2.
Okay, and each of those represents what? How many laps that he made?
Yes, how many laps?
Okay. Okay. All right. So this is how many laps he did, and we want to know how much he needed to finish on Friday. How many laps on Friday?
Yes.
Okay.
And each lap is 400 meters. Was that correct?
Yes.
Okay. So there are a few things first we need to do, right? We need to, what are different things that would help us solve this? Can you share that, or do you want us to go through it all?
I can't. Sorry. Can you say that again?
What do you think we should do first? There are a few things we'll need to do here.
I think we should make a model.
Okay.
Okay. We could make a model. Now, what do you think we would need? What part of this would you like to solve with the model?
I would like to solve the Friday.
Okay, that works.
And
we like that too. So there are a few things we need to figure out. First of all, we need to know how many laps he needs to make to get to the 4,000 meters. Do you see what I'm saying? There are a few different things. We need to know how many laps because we're going to put together how many laps he's already done and how many laps he still needs to complete. So we would need to know how many laps would equal the 4,000. Does that make sense?
Yeah.
So there are two different things. First, we're going to put together, I think what would be helpful, I know we have a model that we're going to do as well. I think it would be helpful to figure out how many laps he's already done. And then we need to figure out how many laps it takes to get us to the 4,000, and then we're going to need to find the difference. Does that make sense?
Yes.
Okay. So how do you think we can figure out how many laps he's already done? We have 4 different mixed numbers here. So what can we do for that?
I think that we can make a model.
I'm doing it.
Okay. Oh, okay. All right. Excellent. So Coach Davis is already working on a model. Okay. So 1 lap is 400 meters, and half of a lap would be how many meters? If 1 lap is 400 meters, how much is half a lap?
200 meters.
What's half of 400?
200 meters,
Oh,
yes.
200. I'm sorry, I didn't hear you correctly then. Okay. We also had some fourths and some eighths, correct?
Yeah.
Okay. So what would 1/4 of a lap equal? How many meters would that equal?
That would equal...
What's 1/4 of 400?
I can't hear you.
What's 1/4 of 400?
1/4 of 400 would be...
4 of what number equals 400?
Or 400 divided by 4.
That works as well. Is how much?
It'll be 100.
Exactly. Okay, so 1/4 of a lap is 100. And then I think we also had an eighth in there, didn't we?
Mm-hmm.
Okay. So then we're going to then find out how much an eighth of a lap is equal to, which is 1/8 is half of 1/4, right?
Yeah.
Okay. So what is half of 100?
50.
50, exactly. So 1/8 of a lap equals 50. Does that make sense?
Yes.
Okay, excellent. So what we can actually do with this information is go back to the table that you just told us about, and we can figure out how much he ran each day. Okay? So 1 1/4. 1 would be 400 meters. 1/4 would be 100 meters. So 1 1/4 means he ran how many? What's 400 plus 100?
500.
Exactly. So Monday, we're going to fill in the chart. He went 500. Okay, so let's go back to the table and let's put 500 under Monday. Okay?
Yep.
Okay, now let's do 1 3/4. So 1 lap is 400, and 3/4 is going to be 3 of these, correct?
Yes.
So how many meters would that total for Tuesday?
It would equal
400 and 3 100s. Would be how many meters?
it will start at
I'm sorry? I think I'm having a hard time hearing you. 400 plus 3 100s would be how many meters?
700.
Exactly. So Tuesday went 700 meters, okay? So we're going to go back to our table, and we are going to fill that in. Okay, so Tuesday is 700 meters, right? Okay.
Yeah.
Wednesday, 1 5/8. So we have 1 is our 400 and 5/8. 5 groups of 50. What's 5 groups of 50?
It will be 2. It will be
5 groups of 50. What's 5 times 5?
5 times 5 is 25.
25. And that's times 10. We can add that 0 back. And that would be
250.
250. So 250 plus 400 equals how many meters?
650.
Exactly. So on Wednesday, he ran 650 meters. So we're going to add that. This is quite a problem you've given us, Keon. I like it. Okay, 2.5. So 2.5 laps. 2 laps would be how many meters? Each lap is 400. So 2 of those would be what?
800.
800, and it was 4.5, correct? 2.5, I'm sorry. So that would be 800 plus a half more is 200. What's 800 plus 200?
1,000.
Exactly. So on Thursday, he went 1,000 meters, okay?
Yes.
All right, so now we have figured out how much he has already ran. So let's add these together. We have 1,000. I'm going backwards here.
650.
650.
700.
700.
500.
And 500, okay? So let's add that together, okay? Okay. Add all our zeros together. It equals
0.
0. 0 plus 5 plus 0 plus 0? 5. 6 plus 7 plus 5. So 6 plus 7 equals?
13
13 plus 5?
equals 18.
18. 8, carry the 1. 1 plus 1?
Yep.
What's 1 plus 1?
2.
Okay. So he has already gone 2,850 meters, correct?
Yes.
Okay. So now we need to find the difference between 4,000 and 2,850, okay?
Yes.
All right. So how do we find the difference? What operation do we use? Exactly. So let's go ahead and subtract. 0 minus 0?
0.
Good. 0 minus 5?
You can't subtract 0.
Thank you. Good. All right. So Coach Davis is regrouping here. We're going to take away the thousands. 4 thousandths becomes 3, and that replaces 10 hundredths. And we're going to regroup one more time. Okay?
Uh-huh.
All right. So in the interest of time, 10 minus 5 equals?
5.
Good. 9 minus 8? And 3 minus 2? Excellent. So he has 1,150 meters to go, correct?
Yes.
Okay, now the question is how many laps is that? So one last thing we need to do is do what? How can we figure out how many laps he has to go? How many meters are in each lap?
You add them up.
Okay. Well, there are 400 meters in each lap, right? So we actually want to see how many 400s go into 1,150, okay? So 1 400 is 1 lap. Another 400, what's 400 plus 400?
It's 800.
800, good. So we need to get to 1,150. Can we do another full lap?
Can you say that again?
Can we fit in one more full lap? Can we do another 100?
Yes.
If we do another 100
no.
right, it would be too many. But it would be really close, wouldn't it? Actually, we can go backwards from there. One more lap would be 1,200, and we would only be 50 short. So actually, we could do it that way. In the interest of time, I'm going to go ahead and do it that way. If we did one more lap, 3 laps would be 1,200, which is over, but just 50 over, correct?
Yeah.
So I know if I'm 50 meters over, I'm actually 1/8 over. So I want to take away 1/8, which is taking away the 50 meters from 3 full laps. Does that make sense?
Yes.
Okay. So if I'm going to take away 1/8 from 3, can you tell me what I have left? Any idea what I have left? If I take away 1 lap, 1/8 of a lap from 3 laps, can you tell me how many I have left?
You will have.
Coach Davis helped you. Okay? 1 lap is the same as 8/8. That's a whole. So if you took one of the 8ths away, we would have 7/8. So he has 2 7/8 laps to go on Friday. Woo! Keon, you got our brains going today. That was a hard problem, but it was a lot of fun, a lot of modeling and different strategies. We persevered in solving that problem, Keon. Did that help you? Hopefully? Did that help?
Yes.
Okay,
All right.
excellent. We were really glad that you called us with that problem, Keon. Thank you so much. Again, if you would like to solve one of those challenge problems, we would love for you to be able to maybe call us back in the second half of the show because we have so many callers today. Okay.
All right, and I think
How many seconds?
Okay, and I think we're ready for our next caller. Ashley, you're listening on the phone. Thank you so much for your patience, Ashley. And are you at Ridgecrest Elementary?
Yes.
Oh, well, welcome to the show,
Excellent.
Ashley, what grade are you?
We're at school.
4th.
4th grade.
Yay.
And who is your teacher?
Miss Rowley.
Miss Rowley. Well, please say a big hello to Miss Rowley for us from the coaches of Count on Us. And what type of problem are you working with today, Ashley?
Multiplying.
Multiplying.
Love multiplying.
Now, what exactly are you multiplying, Ashley?
Well, it's like this word problem.
Okay. Well, word problems are the best types of problems if you have to multiply. Use a word problem will help you out, figure out when and what to multiply, okay?
Okay.
So if you will tell me the problem, Coach Sun and I will attempt to help you multiply, okay?
Okay.
All right.
So 8 is blank times as many as blank, and blank times as many as blank.
Wow, that was a lot of blankety blanks there. So let's take it slow. Okay, I got the 8 is blank times. 8 is blank times.
As many as blank.
8 times as many as blank. Okay, so far so good?
And blank times as many as blank.
Wow! Blank times as many as blank. All right. You know what? Should we use some counters? Because, there's a lot of things that we can do with
Let's see. What do we have here?
Okay, so 8 is blank times as many as blank. So if we had 8 things, we can figure out.
Okay.
How many times 8 is as many as anything we want to figure out, right?
Yeah.
Okay. So do you have counters or something that you can use?
Well.
You could use pennies, beans, noodles, siblings, whatever you'd like to use. Okay, as long as you have 8 of them.
Well.
Okay, so here I have 8 items. 8 is, look at how I have it arranged. 8 is how many times bigger than as 1?
Well, the problem is that I don't have any of Comcast or Verizon.
Oh,
okay. All right, then.
So you're listening, right?
So then, if I use 8 things to count up, 8 is 8 times as big as 1. 8 is 4 times as big as 2. 8 is 2 times as big as 4.
Yes, that's
So
all the factors.
If you think about all the numbers, whole numbers that you can multiply together to get 8, those are the things that you can fill in. And if you thought about it as a multiplication problem, 8 would be the product. So 8 is like our answer is blank times blank. So as long as you filled in the blanks, the two numbers that you can multiply together, those are called factors. 8 is blank times as big as blank. So as long as you use two numbers that will multiply together to give you 8, you could use any of those. So you could use 1 and 8, 2 and 4, 4 and 2, 8 and 1. So all of those would fill in. Okay?
Okay.
Thank you so much, Ashley, and for calling in today and persevering.
Yes.
We appreciate your patience and your diligence.
Yes.
And we do have our lines are just lit up, and we love it, love it.
We are feeling the math love today. We are feeling the Count on Us love today. We can't tell you how much we appreciate it, and we appreciate all those callers who are still holding. We are going to go to a quick break, but please stay tuned because we're going to get to the rest of those calls, and we will be right back on the other side of the break. Stay tuned.
Join us.
Loving all these calls!
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So, 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, sit right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is gonna lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Good afternoon and welcome back to the second half of your initial show for the season of your Telly Award-winning math homework hotline. My name is Coach Davis, here with my fabulous
Thank you, Coach Sun. And I cannot tell you how excited we are because the lines here on Count on Us have been going crazy with all of the math love coming through the line. We love it and we appreciate it, and we cannot wait to help you. So on that note, we already have so many people waiting. So we want to go ahead and get started. So we are going to go, I believe, to Jessie. Jessie, are you there?
Caller, are you there? Caller, yes, welcome. Is this Jessie from Thomastown? Is that you, Jessie?
Yay, welcome, Jessie.
Okay. How are you today?
Okay.
Okay.
Okay, you excited to be on Count on Us?
Huh?
Are you excited?
Yes, we're excited for you.
Yes.
We're just going to let some of this excitement jump across your TV screen or your computer screen and zap you with the math answer.
Yes. Okay.
And you're at Thomastown. What grade are you, Jessie?
Fourth.
Fourth grade?
Okay.
All right.
Yes.
Well, welcome. And you're working a word problem into an equation. So, Jessie, can you help me out by telling me the word problem nice and loud and clearly?
Okay.
Okay.
Henry has 3 gearbills. Anna has 3 times as many.
Hold on 1 second, Jessie. Hold on. I'm sorry. Maybe it's me. I'm having a hard time hearing you.
I didn't hear it.
So if you could, I'm not sure if your TV is up, and this is for all callers. If you could make sure to turn down the TV and just talk into the phone, you can still watch us on TV. That might help us hear you a little better, okay?
Okay, so start from the beginning. When you come to a period at the end of the sentence, stop and see if we wrote it down like you see on your paper, okay?
Okay.
All right, thank you very much. Okay, start again from the beginning.
Henry has 3 gearbills.
Henry.
Anna has 3 times as many.
Menus?
As many.
Oh, okay.
Henry has 3. Was it gerbils, like the little pets, the little animals?
Yes.
Gerbils. Can you spell that for me, please?
Gerbils.
It's an I instead of an A?
Hmm?
Oh, okay. Okay, 3 gerbils. Henry has 3 gerbils, period. Was that correct?
Anna,
A-N-A?
yes,
Has
3 times as many.
3 times as many.
How many gerbils does Anna have?
How many gerbils
Yes. Does Anna have?
does Anna have? I just love this question.
Okay.
Okay. So you are to write an equation for it?
Yes.
Okay, have you used a tape diagram before in class?
Hmm? Sorry, I didn't hear you.
Have you used a tape diagram in class before?
No.
No. Okay. Well, then let's just say that a tape diagram is just a representation for a problem. So it helps us to understand what it is we know and what it is that we do not know. So if I say that, okay, I'm going to modify. This is no longer a tape diagram because you haven't used tape diagrams. But we know that Henry has 3 gerbils. So I'm going to put 1G for gerbil, my second gerbil, and my third gerbil. Is that okay?
Okay.
Okay. And Anna has 3 times as many. So I'm going to put Anna's gerbils. She's going to have red gerbils today. Okay?
Okay.
So here are Anna's gerbils.
Mm-hmm. Okay.
1G, 2G.
So, excuse me, what did you say?
I'm just counting gerbils. So now she has the same number of gerbils as Henry does. But she doesn't have the same number of gerbils. She has 3 times as many, right?
Yeah.
Okay. So this is 1G, 2G, 3G. So now she has 2 times, but that's not what the problem says. It says she has 3 times as many gerbils, right?
Yeah.
1G, 2G, Luigi. So the red is Anna. And the blue is Henry.
Okay.
Now, I'm not exactly sure, how would you like to write this as an equation? There's a couple things I could do.
So, my teacher told me to write a multiplication equation.
A multiplication equation. Okay, so we can say that 3 times Henry's
equals 9.
We could do that. It does equal 9, right?
Yes.
Excellent.
Okay, so we can say 3 times 3 equals 9, and we can say what we're talking about, gerbils.
Yes. Okay.
Okay, is that the type of equation you want, or were you supposed to use a variable for the unknown?
Okay, I'll go with that then.
Yeah, there are a few different ways. We could have done A for Anna's equals 3 times Henry's, which was 3. Okay, there are a few different ways to do it with A meaning Anna's gerbil. So there are definitely a few different ways to do it. But modeling always helps.
Okay, and so our numeric equation is 3 times 3 equals 9.
Okay.
Thank you so much for that call, Jessie. And your name is going into the treasure chest because we treasure all of our callers.
We do.
And we have time for another caller.
Yay!
Caller, are you there?
Are you here, caller?
Okay, give us your name, please. Your name?
Is this Dejan?
Yes.
Okay.
Hi, Dejan.
Welcome, Dejan, to Count on Us. You are on the first show of the new season. Yay! And what school are you calling from, Dejan?
Robert R. Gray.
Robert
R. Gray. And what grade are you, Dejan?
What did you say?
What grade are you in?
6.
6th grade. And are you writing decimals as fractions as well?
Yes.
All right.
Did you see our first caller? Yeah, first caller.
There was another caller that was writing decimals as fractions.
Okay.
Okay, so maybe that will help when we go a little bit faster.
Okay.
Writing decimals as fractions.
Okay, why don't you go ahead and give us the problem, Dejan, okay?
Okay.
Okay. And what is the problem?
4.764.
Perfect. And this is actually a great example from the first caller where it was slightly different, right? Okay.
Yeah.
Can you, and was there another part, or you wanted to write this as a fraction, correct?
Yes.
Okay. Can you read this number to me as an actual number instead of just with the decimal places and the name of the decimal places? Do you know how you would read this? 4 and
764.
Good. What place value is that 4 in? Do you know?
The ones.
Well, when we're talking about it, there we go. Okay. And
a common misconception.
Yes. So remember, anything to the right of the decimal point is actually less than 1, and those place values are different. So to the right of the decimal point, do you know what that's called? Coach Davis is already helping you.
The thousands.
First, we have the tenths. So that's 7 is in the tenths. Thousandths? Okay, yeah. I'm sorry, I was talking about the one just to the right, but maybe I wasn't clear. So awesome. So the 7 is in the tenths place, the 6 is in the hundredths place, and the 4 is in the thousandths place. So when you're reading this, you would read it first just as you would read it, 764, and then you would name that last place value, which is the thousandths. So to read this number, it would be 4 and 764 thousandths. Does that make sense?
Yes.
Okay, excellent. Now, the difference between this call and the call earlier, did you happen to watch that first call?
Yes.
Okay. And do you remember if it was a mixed number or a fraction that we turned it into?
A mixed number.
We actually turned it into a fraction because there was not a whole number to make it a mixed number. Remember, a mixed number has a whole number and a fraction. And this problem that you're giving us actually does. So yours is actually going to turn into a mixed number, whereas hers just turned into a fraction because there was not a whole number. Okay? So that 4 is going to stay just as it is when we're doing a mixed number. So we have 4 as the whole number. And then, just the way you read this to us, we can turn that into a fraction. Okay? It was 764 what? Thousandths. Good. So we can write that down, and that 1,000 becomes our denominator, just as Coach Davis wrote down here. Okay? So this is our numerator, and the place value becomes our denominator. So if we were to write this as a mixed number right off the bat, we would have 4 and 764 thousandths. So it really sounds almost the same as when you're reading it as a decimal, correct?
Yes.
Okay, is this in simplest form? Do you think this is in... Do you think this answer is in simplest form? We found an answer, but we want to make sure it's in simplest form.
Yes.
Okay. Well, let's take a look. We can always look. We want to see if both of these numbers have the same factor, or a factor that can divide into both of these numbers. Since the first number ends in a 4 and the second number ends in a 0, we know that they are both even numbers. And so that means that they could divide by what? 2, exactly. So we're not sure about other similar factors, but we can always just divide by 2 and then see if we can break it down even more, okay?
Now, do you need help simplifying this fraction as well?
Would you like help simplifying? Okay, then we'll try to simplify really quickly.
We can divide by 4 because the last 2 digits are divisible by 4.
Okay.
Okay, so let's try 4.
Okay, so let's try 4. 4 goes into 764. Let's see. 4 goes into 7 how many times?
4 goes into 7.
I'm going to go through and go quickly, okay? Just in the interest of time. 4 goes into 7 one time. 4 times 1 is 4. Remainder 3. Bring down the 6. 4 goes into 36 how many times?
4 goes into 36 how many? That was the question?
Yes.
3.
4 times what equals 36? 4 times 9, okay? 4 times 9 equals 36. There's no remainder there. I bring down my 4. 4 goes into 4 one time, and that goes in perfectly. Coach Davis already wrote it down. So 764 100ths simplifies to 191 250ths, okay?
So we'll keep our whole number.
4 and 191 250ths is your final answer. Does that make sense?
Yes.
Okay.
All right. Thank you so much, Dion.
That was awesome. Dejan.
Dejan. I apologize,
yes.
Dejan.
Thank you so much for calling. Your name is already in the treasure chest, so make sure to stay tuned at the end of the show to see if we pull your name, okay? Okay.
All right.
Awesome.
And we have another caller. Yes!
These phone lines are just making me so happy today.
They are lit up with the love. We love it, love it, love it. All right. Is this Eunice? Eunice, are you there?
Yes.
Hi, Eunice. Are you, do you go to Mount Rainier?
Yes.
And what grade are you, Eunice?
4th grade.
4th grade. And who is your teacher?
Mr. Herman.
Mr. Herman! Mr. Herman, the coach has said a big hello.
He's awesome.
All right. And are you working with multiplying as well?
Yes.
All right. And we're going to ask you to turn your television all the way down and just listen to us in your telephone, okay?
Okay.
All right. So what do you have to multiply?
42 times 5.
42 times 5?
Yes.
Okay. All right.
Okay. Now, there's a couple of different ways that we can multiply 42 times 5.
There is, although since we have a few more callers, I think we're going to go ahead and we might do it, and that's the way I was thinking of. So there are a few different ways to do it, but I love, since we really can, I think, just go ahead and multiply 5 times the 40 and 5 times the 2, put them together, and then we're good to go, okay? Although there are a lot of different ways. So can you tell us what 40 times 5 is, or 5 times 4 tens? What's 5 times 4?
10.
5 times 4?
20.
Right. So 5 times 4 tens means we'd add a 0 to the end. So that becomes what? That becomes That becomes 200, okay? Okay. Now our 2 times our 5 is?
2 times 5, 10.
Okay, good. So let's go ahead and add that. What's 200 plus 10?
210.
Exactly, 210, and that's your answer. So what we just did is we broke it up into partial products, and we multiplied 5 times each of the place values, okay?
Yes.
Okay.
All right, your name is going into our treasure chest. So please stay tuned to the end of the show to see if you are the winner of a fabulous prize.
Okay.
All right.
Thank you so much for calling.
And we have another caller.
We do. This is so exciting. Okay, let's see how many we can get through in 10 minutes.
Okay.
Okay.
Say your name for me. Hello, caller. Are you there?
Is this Makai?
Yes.
Okay.
Hi. Welcome, Makai.
Are we saying your name right?
Yes.
Okay, awesome.
And do you go to Highland Park Elementary?
Yes.
All right. And what grade are you, Makai?
Yes.
5th grade.
Awesome.
And you are working with properties, is that correct?
Yes.
Okay. Well, what shall we do with these properties?
It says write a definition for the associative property of multiplication in your own words and explain how you would use it to compute 4 times 25 times 27 mentally.
Okay. And we have 9 minutes.
Write a definition in our own words and explain how you would use it to compute. Okay, give me the rest of it.
Use it to compute 4 times 25 times 27.
4 times 25 times 27. Okay. Well, how about we compute and let that be our definition? How about that?
Okay.
All right. So if I'm using the associative property, what do you know about the associative property?
Wait, can you say that again?
What do you know about the associative property?
I know about associative property is when you're multiplying, you can multiply any group of addends and any group of addends.
Okay, so we're going to define it as we're working through it. So instead of addends, notice the add part. Addends go with addition. Factors go with product. And you are on the correct path. I can add these. Here I am adding. I can multiply these factors in any order. I can group any 2 together and multiply them in any order. So let's group the ones that would make it easy for us to solve, okay?
Yes.
All right, so I know that 4 quarters equal how much?
4 quarters equals 25.
4 quarters. Instead of 25, I'd count 25, 50, 75, 100, or $1. So 4 times 25, I'm going to put my grouping symbols around them, and that will give me 100. And now I have an easy number to multiply. 100 times 27. So I have 27 100ths, which would give me 2,700, or if I put a comma in,
2,700.
Okay. And so for my definition, numbers can be multiplied in any order without changing the P word.
Product.
Very good.
And then you can also
and
prove
instead
that
of
by
numbers,
by
we can
showing.
also say use the F word up here, factors. Okay?
Okay.
Does that help?
Yes.
All right. Thank you so much for your call,
we
Makai.
really appreciate
And your
it.
name is going into our treasure chest.
That treasure chest is full today.
All right, and I think we might have time for another caller.
Let's see if we
Caller, are
can-
you there?
Squeeze in our next caller. Is this Nina?
Hello.
Hi, Nina. Welcome
Thank
to
you
Count
for
on
being
Us.
so patient.
Yes.
Nina, can you tell us what school you attend and your grade?
I'm in 8th grade and I go to Beltsville Academy.
Beltsville Academy. Okay.
Beltsville Academy. We apologize for your delay, but we appreciate your patience. And your grade one more time?
8th grade.
8th grade.
Awesome.
All right. Love it. Okay, what are you doing in 8th grade? Are you working with rational numbers?
Yes.
Okay. Well, what are you doing with those rational numbers?
The problem is write 5 rational numbers that are not integers, whole numbers, or natural numbers.
Ooh. Love it. Love it. Write 5 rational numbers.
That are not, what can they not be?
Integers.
Okay.
Whole numbers.
Okay.
Or natural numbers.
Or natural numbers.
Ooh, well, in order for them not to be this, we have to know what these things are.
Yes. So what is an integer, Nina?
A negative number and its additive inverse.
Ooh,
I love this vocabulary. Okay, we're going to try to see if we can get this. Okay, what's
a negative 1, 0, 1. Okay, what's a whole number?
A whole number is a counting number.
Okay. Well, actually, with the whole number, we start with 0. So usually when we're counting, that's more like our natural numbers. So a whole number are our 0 plus our counting number. So 1, 2, and I'm going to put dot, 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 3, dot, dot, dot. And our natural numbers are 1, 2, 3, dot, dot, dot. So if I'm making a rational number is any number that can be written as a ratio. So it would have what we would call a numerator and a denominator. So any of them that aren't whole numbers, integers, or natural numbers will fit that definition. So can you give me something that would have a numerator and a denominator?
Negative 3/5.
Negative 3/5.
I like it.
Okay, so that is a rational number. Can you give me so that's 1. Give me another one.
That is a fraction?
As long as I can write it as with a numerator and denominator. So I can make this into a decimal.
That's what I was just thinking.
Okay, negative 3/5 is the same as negative 6/10. Okay, so then that's another one. Okay, so anytime I make a numerator and denominator, I'm making a rational number. So you want to give me some others?
5.3.
Okay, 5 and 3/10. Because I can write that as 5 and 3/10 or 53/10. So there it is.
There you go.
All right, so you got the hang of it?
Yes, I did.
Okay, do we have 5 of them for you, or you can complete it?
What? Can you say that again?
Is that good, or would you like for us to give you all 5?
No, I think that's good. Thank you.
Okay, that was a great question.
You're welcome. Thank you so much
Thank
for being
you
so patient.
so much. Now,
all right.
We cannot tell you how much we have loved all the callers coming in today. We wish this show could go on like till midnight so we could take all the callers. But here's what we would like to do. First of all, we would like to thank the first 5 callers. Your teachers are going to get a prize. Andy from Beltsville, Andy, Keon, Ashley, Nina, and Jesse. Your teachers at Beltsville, Allenwood, Ridgecrest, Forestville Academy, and Thomas Stone, your teachers will be getting prizes on their way. And I didn't know that. And you will be getting them. So you and your teachers will be getting prizes. That is totally awesome. And if you are still waiting, we have had the phone lines lit up. We are so excited for the season. So hold on. If you have been holding, we truly appreciate it. And in a few minutes, next awesome crew is going to be coming for the next show from 5 to 6. Stay tuned. Keep the calls coming. Keep them coming all season. Count on Us will be Mondays and Wednesdays from 4 to 6 p.m. We cannot wait for you to join us. We are going to pull one name from all of these names. All of these names in the treasure chest. Here we go.
All of them, and our lucky winner is Makai from Highland Park Elementary.
All right. Stay tuned.
Remember, every Monday and Wednesday you can join your Telly award-winning homework hotline from 4 to 6 p.m. and you can always count on us.
Have a great afternoon. We'll see you soon.
Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now to set up our answer, the whole number here becomes our whole number for the mixed number. And then the remainder becomes the new numerator. And guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
to solve math?
Many.
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times width plus 2 times width.
Hey, welcome back. You're on the second part of our TV show. This is the intermediate, secondary, the big time for all you higher up people who have these good questions for Count on Us. My name is Ted Herman.
And I'm Miss McCants.
My lovely partner I just work so well with every year. And as long as I keep sending her checks, she gets along great with me. So I keep those monthly checks coming in, and everybody's happy on Count on Us because when you call in, you're happy because we're happy when you're happy. You happy?
Welcome back.
Welcome back to another school year of Count on Us, your favorite math call-in TV show live, and it's 301-772-0080. What a memory. And how about the webcast? How do you get on the line?
I think they go to the PGCPS website,
right,
and they go to homework help, students. Okay.
Okay, that was good.
All right, so I think we have.
That was incredible.
We have
so
flooded.
Smooth.
We're flooded with callers.
We're flooded with callers. Okay, let's go to the.
But before we get to the callers, we need to go over our 24 challenge.
24 challenge.
Okay.
Oh, we're so smooth.
So do you remember the rules for 24 challenge?
I have no idea.
Okay, so they are to create the number 24 using any operation, multiplication, addition, subtraction, or division.
Oh, okay.
A combination of those.
Okay.
And they have to use all 4 numbers. And this is a 9.
Because it's colored in red.
Because it's colored in red. 3, 2, 14. That's card A. Card B is 7, 1, 5, and 4. Card C is 7, 2, 6, 8. And card D is 8, 5, 2, 8. And they have to use, you have to use both of the 8s. You have to use all 4 numbers.
All 4 numbers. And I think when 3 dots show up, that's a more challenging, higher level problem. So you got to do some thinking. So before you get on the air with us and you want to get in our treasure chest twice,
that's right,
answer your question on the air and do the challenge 24, and that gives you a good shot of winning a prize.
Yep.
Let's go to our first caller out there, who I think is Kayla. No, Sariana.
Yep, Sariana.
Did you want to do Sariana? I got Sariana.
You can
That's
have Sariana.
Right. Sariana, you out there?
Yes.
Hey, Sariana, how are you today?
I'm fine.
What school are you calling from?
Potomac Landing.
Potomac Landing. So tell your teachers we said hello at Potomac Landing. What's your question today?
Just 1 second. Sariana, is your TV on real high? Or I got a buzz in my ear. I don't know what it is. Is your TV up real high?
No.
You got to turn TV all the way down or put it on mute because we can hear you,
I can hear
ourselves
you.
on your TV.
I hear you feeding back in my ear. Can you just lower your volume all the way down?
Yes.
Okay.
Okay, let me know when you have the volume down on TV.
Okay.
Thank you. Okay, I still got a buzz, but I'll keep on going. What's your problem about, Sariana? Let's go ahead and attack that.
It's the volume of each rectangular solid.
What is a rectangular solid, by the way?
It's a 3D rectangle.
I like that. Good description. Those Potomac Landing people know their stuff. Is this about geometry?
Almost. It's measurement and data.
Okay, measurement and data.
And measurement and data. Well, that's a high level. I wasn't expecting that kind of response. So sorry for bringing up the word geometry and being so inferior. So go ahead and give me your dimensions of your 3-dimensional volume, rectangular solid.
On the left, you draw a rectangle.
One second.
Sorry.
Is this a rectangular prism or rectangular pyramid?
Rectangular prism.
Excellent. which means it has a rectangular base, right?
Yes.
And how many bases should we have?
You should have 1, 2, 4.
Well, the base should be the top and the bottom. So how many bases do we have?
Bases?
Base. The rectangular.
2.
There you go. Because like this solid right here has a top base and a bottom base. So you're on the right track there, Sariana. Am I saying your name right?
And did I draw the word?
Sariana, is that name right?
Yeah.
Nice drawing. Look at Miss McCants go.
Almost.
It
But
looks
you can start
terrific.
giving us the dimensions.
Yeah, if you have some dimensions like length and width and height, that'd be great.
It's correct.
Okay, great. So how do you, what's the dimensions on this, Sariana?
On to the back, on top,
Mm-hmm.
Back here?
put a 2. Yeah. A 2.
2 what?
That's it. And
Yeah,
then
what's your measurement?
They didn't give you a unit of measure?
the length is 5. The height is 2. And the width is 2.
The width is 2?
So you're saying it's 2, 5,
Right.
and
2 more, I think, believe, right here. But do you have, is it measured in a centimeter or millimeter or inches or what?
Centimeters.
centimeters.
Oh, great, 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 great. And do you know the formula for volume of a rectangular prism?
Okay. Okay.
Okay, let me give you a hint. How about...
Just to say that again?
We're trying to have a fight with our pens here. L, now Miss McCants, times, that's a little dot for times.
W times.
Oh, she's so sweet and good. Help her. Oh, my goodness. Length times width times...
Height.
Height. Excellent. So let's plug in our numbers, Miss McCants, and we'll go for it.
Okay, so it's 5 centimeters times 2 centimeters times 2 centimeters.
Yeah.
And can you do that, Sariana? Nice job, Miss McCants. 5 times 2
It's 10.
times 2.
20.
Excellent. But here comes the kicker. When you put down the 20, how do you label it? By the way, how many dimensions does it have?
You gave us the length, the width, and the height. So how many is that?
That's 20 centimeters, which is 20 cubic units.
Oh, my
Love
goodness. So some people actually can put a 3 up top to means 3-dimensional. Or you could write, I don't know how your classroom does it, CU. What's CU? You just said it just now.
Cubic.
Cubic centimeters. Oh, my goodness. So, Sariana, you're on the board. You're the first one to get into our box, our treasure chest of fame, and you have a chance to win a prize. Did you want to try the 24 challenge real fast?
Did you want to try the 24 challenge?
A challenge?
Yeah, the 24 challenge.
Were you watching the opening of the show? We went over all the numbers.
Yes.
Do you want to try one, or do you want to call back?
I want to try one.
Okay, I'm going to put it back on the screen for you.
Beautiful.
Which one would you like to try?
The second one, at the bottom.
B or D? This is B.
B.
Okay, B.
B as in boy?
Yes.
Okay. So let's move that out of the way and go
So
right
your
for
numbers
it.
are 7, 1, 5, 4.
7, 1, 5, 4. Okay.
Do you want to write down the numbers and then give us a call back after you worked it out? You can do that.
7 times 4.
I can call back. Okay.
That's a great idea.
So
great
give us
idea,
a call back when
Soriana.
we'll work it out, okay?
But nice work on your volume, and next caller is going right to Miss McCants.
Okay, so who do we have next? Is that Kayla?
Yes.
Hey, Kayla, how are you?
Yes. Huh?
I said, how are you doing?
Good.
So, what school do you go to?
Bladensburg Elementary.
Say that one more time. Bladensburg Elementary.
Yes.
Oh, I know where that is. Is that in Bladensburg?
Yes.
I knew it. I've seen that. Yep.
So, what's your question today?
Huh?
What's your question?
It is math. It's a word problem.
Okay, so read the word problem to us.
Pardon me?
Read the word problem to us.
Okay. Tina has $35 to spend on socks. For the family, and each pair of socks costs $5. How many pairs can she buy? Write a division sentence.
Each pair of socks costs 5 cents or $5?
Dollars.
Oh, okay.
Okay, each pair costs $5, and you need to create a division sentence?
Yes.
Okay, so you want to know how many, are you trying to solve for how many pairs of socks she can get?
No, I'm trying to find how many pairs does she buy.
Yes. Okay, we're saying the same thing. You want to know how many pairs of socks can she buy. So if she starts out with $35 and she is spending $5 on each pair, we could do repeated subtraction.
Division.
Yes, we could. Repeated subtraction is division. Okay? So basically I'm saying I'm going to take the $35 and I'm just going to subtract $5.
Okay.
Okay, so that's one pair of socks. Does that make sense?
Yes.
So how much is left over if I'm taking $5 from the $35?
Excuse me?
Subtract 5 from 35.
Okay. 30.
30, excellent job. So now I have $30 left. If I take another $5 for another pair of socks, how much would that be?
It will be $25.
$25. Okay. So we're going to just keep subtracting $5 until we don't have enough money to spend on a pair of socks. Is that okay?
Okay.
Okay, so now I have another pair.
20.
Excellent job. I'm going to slide this over a little bit. So I'm going to take my $20 and bring it over here. Subtract $5 from that.
$15.
Okay. Keep going.
10.
Okay, one more time.
5.
And I got enough to buy one more pair, right?
Huh?
Do I have enough to buy another pair?
Yes.
Okay, now we don't have any more money. But let's count up how many pairs of socks we can buy. You ready? 1, 2, 3, 4, 5, 6. How many pairs of socks can she buy?
8.
Let's count again. 1, 2, 3, 4, 5, 6, 7.
9.
What?
So,
what?
Are you looking at the screen? I'm right here. 1, 2, 3, 4, 5, 6, 7.
7.
Excellent job, Kayla. I knew you weren't paying attention the first couple of times. 7 pairs of socks. Okay?
Kayla, are you watching on TV right now? Can you see what's going on the screen?
Yes.
Okay.
Well, by next week, buy a bigger TV, will you? Because I think you missed one. Well, she got it, right?
She got it. She got it.
Can we show the other way of doing it?
Sure.
Thank you very much.
Mr. Herman wanted you to see it this way also. If we have $35 and we have $5 to spend on socks, if each pair of socks is $5, we can divide the $5 into the $35 and have 7 pairs of socks left over. We can buy 7 pairs of socks.
Okay.
Okay.
That's great. Kayla's really, Kayla got her name into the treasure chest one time. Did she want to try the challenge problem with you?
Did you want to look at the challenge problems and give us a call back?
No.
Okay. Well, I hope you have a wonderful night, and tell your teachers at Bladensburg we said hello from Count on Us, okay?
Okay.
All right. You have a good night.
Okay.
Keep doing great things out there.
All right. Victor is for you. He's calling for you, Mr. Herman.
Oh, goodness. He's calling. I can almost hear him. Victor, are you out there?
Hello?
Hello. Hey, Victor.
Hello?
How are you? What grade?
Hello.
What grade are you in?
I'm in 4th.
Way to go. And does that mean like last year you were in 3rd grade? All right, get back to me. How about what school are you at? Thomas Stone?
Yes.
Fantastic. So what do you want to learn about from Thomas Stone work? Give me a problem.
My problem is that it's a word problem.
Mm-hmm. Can you read it to us?
Yes, it says Danny needs 6 times as many red beads as gold beads. She needs 7 gold beads. How many red beads does Danny need?
Okay, can you read it to me a little slower? It says Danny needs 6 times as many.
Danny needs 6 times as many red beads as gold beads.
Okay, stop right there. As gold beads?
Yes.
Okay, and you can continue to read.
She needs 7 gold beads.
Ah. Sorry. Sorry about that.
She needs 7 gold beads?
Yes.
Anything else?
How many red beads does Danny need?
Oh. Well, you know what, Victor? A lot of word problems. A lot of word problems are all about knowing what the words stand for. Because all the words in a word problem can have meaning to them. Thank you. So let's go see what 6 times means. Do you know which sign times would be best for? Let me just go look at some signs real fast. Watch this. I'm going to put a few signs on the paper, and you tell me which one times stands for. Here they go. They're going right in place of times. One's addition, subtraction, division, and multiplication. Do you know which one we could replace times with?
Multiplication.
Man, I'm so glad you called in, Victor. You know your stuff, Victor. So we're going to put times in place of we're going to put multiplication symbol. Thank you so much. So 6 times as many red beads as gold beads. She needs 7 gold. Wait, she needs what? How come it changed from beads to beans? Now I'm concerned. This problem is very confusing. So since you have a transformation from beads to beans, that could be some kind of a problem for us, because now we're going to multiply, I think. We're going to multiply 6 times what we know. And what we do know is she has how many gold beads?
She needs 7 gold beads.
I don't think that's what he said. Can you read it one more time, please? Because I think I have a confusion with what I heard.
Okay. Danny needs 6 times as many red beads as gold beads.
Right.
She needs 7 gold beads.
Oh. So we're going to take the 6 that was given to us. All right, now you're back on the air. This is your chance to be a star, Victor. 6. What are you going to do with those 2 numbers, Victor?
Excuse me?
Okay, watch this, Victor. Drum roll. Booyah! Yeah, come on, Victor. What are you going to do with the 6 and the 7?
6 times 7.
You are, you know, with all the stuff going around my head right now, fingers going this way and all that stuff going that way, your brain is in charge of your body. Nice job. So 6 times 7, do you know your math facts pretty good?
Yes.
So what's 6 times 7, Victor? We're on live TV.
Do you need us to draw a picture?
37.
Oh, that's so close.
Almost.
I'll give you a head start. 40-something, do you know?
47?
Okay, nice job.
47.
42. Nice work. So 42. Now, which color beads we talking about? Gold, red, or gold or red?
Gold.
Good job, red. Because I thought you said the question said, read off this question to me. How many
red beads?
Do you see it on TV or are you not watching TV right now?
Yes, I see on TV.
Okay, so how many what beads?
Yes.
Red beads.
Red beads.
That's right, Victor.
And that would be red beads. That's
not beans.
Not beans. No, but that was really well done.
That was a good question, Victor. I'm glad you called in. Did you want to try the 24 challenge?
Yes.
Yes.
Great.
Okay, so
What
we're going
a-
to put the challenge up here for you.
And I'm putting his name in the
Treasure
chest. Yes, I lost my
So
count.
the cards are up. What we're going to ask you to do is to write down the card numbers that you want to try out and then give us a call because we're about to go on break. So here is card A, card B, card C, and card D. So write those numbers down. So you have your card?
Yes.
Okay, so did you write down the numbers?
Yes.
Okay, so we're going to hear from you in a little while, okay?
Okay.
All right, talk to you in a few minutes.
There goes your name, Victor. Nice job. Do we have time before the break? One more
I think we
caller?
have time for one more caller.
Is that okay there? Great. Well, I guess it's Maria. Over to you.
Okay, Maria, are you there?
Yes.
Hey, Maria, what school are you calling from?
Beltsville Academy.
Beltsville Academy. What's your question today?
It's about decimals.
Decimals? Can you read it to us?
Yes.
Okay, we're listening.
You have to finish a race in 7/8 of the time you ran in the semifinals in order to win. Your semifinal time was 25.6 seconds. What does your time need to be to win the race?
Can you go over that first part again? I couldn't hear. I thought I heard a fraction, but I'm not sure. Can you say the problem again one more time, Maria, please?
Okay.
Thank you.
You have to finish a race in 7/8 of the time you ran in the semifinals in order to win. Your semifinal time was 25.6 seconds. What does your time need to be to win the race?
So it's 25 6/10 of a second.
I'm glad you said
Yes.
that.
Okay, so you 7/8 of the time. That was the beginning of the problem, right?
Yes.
And then your 7/8 of the time for your semifinal.
Yeah.
And your semifinal time was 25 6/10 of a second. Do I have this correct?
Yes.
All right. So of is very important. Of is a very important word when we're dealing with math, okay?
Excellent.
Yes.
Excellent.
Of is telling me, and I'm not sure if your teacher has already gone over this with you, but it's telling me that you need to multiply, okay? So whenever you see the word of, you need to multiply. So 7/8 of 25 6/10 because they said we're dealing with the semifinal time, and you need to beat this time by 7/8, correct?
Yeah.
All right, so 7/8 of 25 and 6/10. Mr. Herman, should we change this to a decimal, all decimals, or should we change everything to fraction?
Fractions would be better.
You think fractions would be better? I like fractions too.
Well, I think the question was asked towards me, but now that I have a chance to respond, I would say you're both right.
So how do we change 25 and 6/10 to a fraction? What would that look like? We know we're going to have a whole number, correct?
Yes, it will be 25 and 6/10.
6 over 10.
Over 10.
That's
okay.
because you said
Good for
6/10.
you.
We know it's going to be 6 over 10. And we have 7/8. I'm going to just bring that down. And of, what did we just say of meant?
Multiply.
To multiply. I'm going to use the raised dot for multiplication.
Okay.
So before I can move on to my multiplication, I know I'm going to have to change my mixed number to something. What do you think I'm going to change this mixed number to?
Improper fraction.
Excellent job. We're going to change this to an improper fraction. And how do I do that? What's the first step?
You're going to multiply 10 times 25.
Wonderful. So 10 times 25 is how much?
250.
Plus 6 is? Plus 6. 250 plus 6?
261.
256 tenths. Because we're saying 250 plus 6. 256. Okay?
Yes.
So now what do I do? How do I multiply two fractions?
So you're gonna first multiply the numerator.
Mm-hmm. Can I make this smaller, Mr. Herman? Can I do cross simplification first? I think I can.
Yes, you could. I think 8 and 256 are nicely divided by some common factor.
I think it could go 4, and then this will be.
I think you can go in 8.
You think I can go 8?
No, I think you can go in 4. Did I say 8?
You said 8.
Well, I lost control of my mouth for a second.
Okay. 256 and.
Let me see real fast. Divided by 8. It goes in 8. I will tell you.
So we can do 1 and
32.
32. Okay, so we can cross simplify before we get started using 8. So we simplified 256 divided by 8, and that gave me 32. And 8 divided by 8 gives me 1. Okay?
Yeah.
So now we're going to multiply straight across. 7 times 32 is going to be, I think, 121. I'm trying to do this fast. 14 here to 1.
Want me to give you a little help? 7 times 32?
224, I think.
It will be 224.
Yep.
Nope. Sorry, it's 224.
1 times 10 is?
10.
10. And now we're going to reduce it, right?
Yes.
Okay, because we cannot have this as an improper fraction. This will go in 22 times with 4 tenths left over.
Yes, and then I'm supposed to simplify to the nearest fraction, so you can simplify it.
Okay, I'm going to simplify it for you. With 22 and what? What does 4 tenths reduce to?
You could divide it by 2, so it will be...
You know what?
2, yeah.
Yeah, right.
Excellent job, Maria.
Can I do one more thing?
Mm-hmm.
Because if you did, well, that's fine. If you wanted to keep it as tenths, it wouldn't be the worst thing either. You could write it like that, right, Maria? How do you say that number?
22 and 4 tenths.
Exactly.
Oh, my, that's it. You get a ring.
So, Maria, your aunt...
Beautiful.
So your answer
Excellent.
is either going to be 22 and 2/5 or 22 and 4 tenths, depending on how you write it. Okay?
Yes, thank you very much.
You are very, very
sweet.
welcome.
And you're in Maria's in the box?
You're in the box, and if you didn't get a chance to get a look at our 24 challenge, there it is, and we're going to leave it up there
Great.
for a few seconds.
And is it time for a little intermission break?
I think it's time. Maria, get that down and give us a call back if you want to try out one of the 24 challenge.
We got a lot more callers calling in, And we hope you stay tuned and watch the break. We learn some more information and come back to the second half of the show.
Okay, thank you.
You're welcome.
Hi, I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is around. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches. And the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So, that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly.
I wanted to be a cowboy.
Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Hey, welcome back. I see you stayed tuned on your TV set with us. We're back on Count on Us, and we're here to answer all your math questions the rest of the day. So, I think we're going to go right to our first question.
Did you want to review our 24 challenge?
Not really. Let's go to our first. Okay, let's go check it out.
I think we should go over the
check
24
it out.
challenge.
Some people might have tuned in late.
Yeah.
How dare they? But here's the numbers you can look at.
Give them the number so they can call us.
14932. Call that number and see what happens.
And the number is 301-772-0080 if you're just joining us.
Or get on the computer and go to the World Wide Web, www.pgcps.org, and come on down the screen to podcast, and you'll find our show. All right. Our first caller on the second half of the show is called Alana. Is that how you say your name, Alana?
He keeps kicking me. Why is he kicking me for? So sorry.
Alana.
Turn that TV all the way down, Alana. I can't really hear what you're saying. TV.
Hello.
Hello? Is your TV down? Hello?
Hello.
Hello?
You okay?
I can still hear you
So
feeding
put
back.
the TV on mute.
Can you put the rest of the people in the room on mute? Can you just turn it down? No, I can hear you calling through my ear, so I might have to lose your call. See, I can still hear. Okay, next caller is Kristen. No, Naomi. Hey, Naomi, how are you today?
Naomi?
Hello.
Hi.
Hi.
How are you?
Good.
So, we see that you called us today. Do you need some help with your homework?
Yes.
What's your math question?
12 times 10.
Wow.
Can you do that? Can you handle it?
No.
12 times
I used to be able to handle it.
10. 12 times 10. Mr. Herman, are you going to take this one?
Oh, sure.
Or do you want me to take this one?
I don't mind. I'll take
Okay,
it because
sure.
somebody's making a decision about who's
Oh,
taking it, so I'll do
no.
that.
Oh, no.
Well, let me ask you this, Naomi. When you multiply, Naomi, how do you multiply? Do you put the two digits on top of each other and multiply?
Yes.
Great. Well, I'm going to show you a shortcut. What's on the, well, I'll tell you what, I'll do my shortcut first, and then I'll do the problem for real second. So, what's 8 times 10, Naomi? Just spout it out real fast. What's 8 times 10? Yeah, I made it messy.
80.
Oh, look at that, Naomi. You are so great. Now, let's say I get rid of the 8 and I make it a 5. What's 5 times 10?
10 times what?
5 times 10. 5 times 10.
50.
Oh, Naomi, you're my favorite caller right now at this moment. And how about, give me any number in the world, Naomi. Give me any number yourself. Good. How about 7? What's 7 times 10, Naomi?
20. 100.
Okay, let's get back to the problem then. That would be 70. Thank you so much. And I was hoping you'd say 12 times 10. Every time we multiply by something by 10, what do we put on the end of the number? Remember the 8 become an 80, the 7 became a 70. Excuse me, sorry. Everything got a 0 on the end of that number when we finished multiplying. So let's go see if we get a 0 on the end of our problem. What's 0 times 2, Naomi?
2.
Okay, hold on. What grade are you in again? I want to make sure I'm not going too fast. What's 0 times 2?
0.
0. What's anything times 0?
0.
Oh my goodness. So if we go 0 times 2 is 0, then what would 0 by 1? 0 times 1?
0.
Yeah, you're getting the hang of it. And then we know we have to put a 0 down in our second row. We're done with this 0 because now we're multiplying by a 1. But is the 1 in a 1's column or is the 1 in the 10's column?
In the
what?
In the 10th place.
Yes. And we just learned, just doing that last problem a little bit, that anything times a 10 with a 0 on the end gets a 0 in its place. So what's 1 times 2 now, Naomi?
2.
And what's 1 times 1?
1.
Oh my gosh, you're almost there. Now what step do we do, Naomi?
What did you say?
What step do we do now? Okay, we're going to add them up. So what's 0 plus 0, girl?
0.
Yes. What's 0 plus 2?
2.
Excellent. And what's 1 plus nothing in front of it?
1.
Oh, Naomi, what'd you get for an answer?
120.
Excellent
No,
job.
wait a minute. I'm sorry, Miss McCants.
Oh, I'm sorry.
How do you say that right, Naomi? Come on, you can do it.
What place value?
In a big 3rd grade voice. 1.
20.
What's the place value of the 1?
Is that in the...
100.
There you go.
Read the rest. 100.
20.
Excellent
Yes.
job.
Bing, 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 bing. And what were we doing before? I got a little message about doing multiply across. So let's go multiply across. I'm going here. Okay. And 12 times 10. We just realized, Naomi, it's the same 12 we have over here. But what do we add on the end when we multiply by anything with a 0 in it? Any 10 number.
0.
Oh, Naomi! You are some kind of good girl! I love it! Yes, I do! So guess what? You get your name in our treasure chest for being a great caller. And you know what? Even if you're a 3rd grader, call anytime you want, because we'd love to have you with us. Okay, Naomi?
Bye. Thank you.
Thank you. You're awesome. And you got your name into the drawing of a special treasure chest. It's all for you, Miss McCants.
Bye, Naomi.
Bye.
Is she still there? Oh, bye.
So, Christian?
Kristen, yes.
Hello? Hi.
Kristen's got to turn his TV set down. If that's a boy or even if it's a girl, I don't care what. He's got to turn the TV set down.
Christian? Or Kristen?
Yeah.
Which one is it, Christian or Kristen?
Kristen.
Kristen. Okay, hi, Kristen. Can you turn your TV all the way down or put it on mute?
Oh, yeah, I hear it.
Okay, you ready?
Yeah.
You know where the volume control is? Turn it down, please. Hey, you at Templeton? Do you know Miss Walters? Okay, back to you. Nice job.
Okay, so Kristen, what is your problem today? I see we're working on a word problem with you.
There are 25 dozens of cookies in the bakery. What is the total number of the cookies at the bakery? Show your thinking using words, numbers, or pictures.
Okay, so do you know how much is in a dozen?
No.
Okay, so when we're dealing with dozen, that is really saying that we have 12.
Okay.
1 dozen means 12.
Okay.
Okay? So if we have 25 dozen, that is really saying we have 25 groups of how much?
12?
Yes, 25 groups of 12. So here it is. 25 groups of. And I don't know if you were watching earlier, but this word of means to what?
Multiply?
It means to multiply. So I have 25 times 12. Can you help me out?
Equals.
What grade are you in, Kristen?
4th.
You're in 4th grade?
Yeah.
So can I change this 25 and write it vertically? Can we do it this way?
Yes.
Okay, so what's 5 times 2?
10.
10. I'm going to regroup, and I'm going to say 2 times 2 is how much?
4.
Plus 1 is?
5.
5. Excellent job. I'm going to put a 0 here as a placeholder, and now I'm going to multiply 1 times 5 is how much?
0.
1 times 5.
5.
Excellent. 1 times 2?
2.
2. So now we're just going to add, okay? 0 plus 0 is 0. 5 plus 5 is 10. I'm going to carry my 1 to regroup. 1 plus 2 is 3. Our final answer is 300. We have 300 cookies. 300 cookies in the bakery. Okay?
Okay. Yeah.
Was that it?
Yes.
Okay.
Yes.
You got it? And remember, 1 dozen equals 12. Okay?
Okay.
Kristen
all right.
gets...
Kristen, your name is going in the treasure chest. Mr. Herman has already written it up for you.
And we're going to go right to our next caller because there's so many callers still left in the air. And we want to get as many calls as we can today. So let's go to our next caller, who is Craig. Is that Craig?
Yeah. Yes.
Do
All
I
right,
know,
Craig.
Do I know you, Craig?
Huh?
Do you know Mr. Herman?
Yes.
Yes. It sounds like you know him. He's waiting to take your call.
How do you know me, Craig? I think you sound very familiar.
Okay.
Oh, it's Craig.
Okay.
Yeah, Craig.
You're my student in the morning. How you doing, Craig?
Good.
You have a problem you want to give me, please?
This is like a good one right here.
Okay.
It's a good one.
Yeah.
All right.
This is a decimal one.
Decimal. I haven't taught decimals. Okay, go ahead.
Okay. 24.53 times 5.
24 and 53 hundredths times 5.
Is that the way your problem looks, Craig?
Yep.
Great. You're right on the ball, and I'm very proud of you for calling in, Craig. So I'll give you an extra Eagle Eye for tomorrow's Eagle Eye store. Okay? 24 and 5300. I'm so glad Miss McCann said it so beautifully out loud. Multiplied by 5. And here we go. Craig, I'll tell you one thing about Craig. I know he's really good on his math facts. 5 times 3.
15.
Look how he goes. 5 times 5.
5 times 5, 25.
And 1. And 1. 20.
I said 25.
Yeah, I know, but then you have to add the 1. Remember that part, Craig? Didn't we learn this in class? Remember this? Okay, that's 26. Let's try it again, Craig. What's 5 times 4, Craig?
5 times 3.
5 times 4.
5 times 4, 20.
Yes. And the 2 up top makes 20.
The 2 on top.
Good. 22. Outstanding, Craig. And we put a 2 right on top of that. 5 times 2, Craig.
5 times 2 is 10.
Plus the 2 up top.
The 2 on top.
Five times 2 is 10. Plus 2 is how much? 11, 12.
Very good, Miss McCants. And we always move it 2 decimal places at the end, and we're just in time for our next caller. Nice job, Craig. Your name's going right into our treasure chest.
Okay, so thank you very much for calling us. Call back on Wednesday.
That was terrific.
All right.
I'll see you tomorrow in class, Craig.
Goodbye.
Yeah, goodbye, buddy.
Sariana, are you there?
Yes.
Hey, what's your question?
I couldn't figure it out.
You couldn't figure out the 24 challenge?
No.
Okay, I'm sorry to hear that. Did you want to look at the numbers again?
Yes.
Okay. There they are. So which card did you have? 7154?
Yes.
Okay, try card A. That's the easiest one on the page. 14, 9, 3, and 2.
But
I think I figured out card B, but I can't help you.
That's nice.
Okay.
I wish I could give you a hint, but I think I would get in trouble.
That sounded motivational for a second.
But you could really get card B if you looked at it. Just look at it a little bit longer.
Can we try another call real fast?
Sure. Sariana, call us back.
Because I have a student waiting to see me. I want to talk to Elizabeth when you get a chance. Let's go to Christopher.
Okay.
Okay, you got it?
Thank you, Sariana.
Yeah.
Okay.
You're great. Okay, we're on to Christopher.
No, we're talking to Elizabeth.
Oh, can I talk to Elizabeth?
Sure.
That's my student.
Okay.
Elizabeth!
You got so excited about it.
How are you?
Hi.
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 Aren't you want to be one of the best readers in 4th grade this year, right?
Yeah.
Okay, Elizabeth, what is your question?
Yes.
I got a problem on number 17.
Okay, can you tell us the problem, because we don't have the problems in front of us?
I can't see that far.
It's
Adrian
has 4 boxes of action figures.
Cool, good reading.
There are 12 in each box.
Oh.
Alec have 21 action figures in each of his 3 boxes. Who has more action figures?
Oh,
to a friend.
Oh, these are 2 separate people. One person has 4 boxes of 12 in each box. And
person 1 and person 2.
I like that. And the other one has 24 in 3 boxes, 24 in each box. Okay. So I'm going to hurry it up right now. Okay. So 12 multiplied by 4. Elizabeth, do you know how to do that real fast? 4 times 2 is what, Elizabeth?
48.
Good job. 8. And 4 times 1 is what?
40.
Excellent.
4. Okay. 4. And then 24 multiplied by 3. Let's find out who has more action figures. 3 times 4 is 12.
21.
3 times 2 is 6
plus
7.
1 is 7. So
who has more?
Friend number 2. Whoever you said.
21.
What?
It's
no,
21.
It's 24 in each box. 24 in 3 boxes and then
21 action figures.
So it's 21.
Oh, it's 21, not 24?
Yeah.
Okay.
Okay. I still think
it.
that's going to change it, but not by a whole lot as far as who's the winner. 3 times 1 is 3. 3 times 2 is 6. And you know what? Elizabeth goes into our treasure chest, so we have a chance to pull our winner for today. Nice job, Elizabeth.
Okay.
I'm going to have my lovely, lovely partner pull out a name out of the box.
Hurry.
Before it's too late to even win a prize. And go ahead, Miss Wonderful. Great partner.
Sariana, you are the winner.
And always call us on Mondays and Wednesdays.
from 4 to 6.
Always count on us. Yes.